Hi, I am Moindrala. I will be presenting improving few short part segmentation using Coarse Supervision. This work was done with Zezu and Subhranshu from UMass Amherst. How do we use a dataset with coarse labels for learning part segmentation? Coarse labels can be bounding boxes, key points, figure ground masks. An assumption to simplify the problem is that coarse labels are independent given the part labels. The graph to the left denotes the same, that once we estimate part labels, we can estimate the coarse labels from them reasonably well. In our paper, as an example, we consider key points, figure ground masks as the coarse labels. We show empirically that the assumption holds. That is, a model that takes only part labels as inputs predicts key points better than a model that takes images as inputs. In our approach, we use a EM-based algorithm where we treat part labels as the latents. As an example, let us consider key points and masks as coarse labels. We essentially have three functions which estimate part given image, key points given part labels, and masks given part labels. The first two functions are deep networks. For estimating masks from part labels, we just sum over the probabilities of the foreground pixels. This gives us the following equation to optimize. In the E step, we maximize Qy, which is the distribution of the latent y, given known relations of part given image and the coarse labels. For solving the EM, methods like hard EM and Langevin dynamics will require a lot of gradient iterations and can get stuck in a local minima since y is very high dimensional. Instead, we use an amortized approach where we use a deep network to learn the dependencies between labeling styles. As datasets for evaluation, we use two kinds of datasets, PASCUB and OID aircraft. PASCUB has the bird images from both the Pascal and Cub datasets. For both the bird and aircraft datasets, we create a small subset for which we use the part labels. For the rest of the dataset, only their coarse labels are used in learning. For the Cub subset, we annotate the part labels ourselves since they were not available previously. We evaluate against four baselines. For each, we initialize with a model that has been trained on a supervised task such as ImageNet classification or Cub key point detection. Fine-tuning is self-explanatory. Multitasking tries to learn to estimate coarse labels as well as part labels using separate decoders and one single shared encoder. Pseudo-sup trains two encoders from pseudo-supervision from each to the other. We also provide supervision from part labels and masks to this. Point-sup uses key points manually associated to parts as point supervision. It is also provided masks and part labels for supervision wherever available. We show qualitative results where we compare our method with the previous baselines, and as is visible, our method shows a significant improvement. We also show some of the failure cases which are bordered in red, but again here also our method performs better than the baselines. We show some quantitative results and the training time for each method, and we can conclude that our model outperforms the baselines with reasonable efficiency. So visit our page for more results, and thank you.